Welcome back to 205G Part 3. Now, in this part, we're going to be looking at Objective 3 and Objective 4 together. First, we need to deal with capacitor discharge circuits. The entire purpose of a capacitor is to store charge, and for safety reasons, capacitors should be automatically discharged when they're not in use. Otherwise, they could potentially be having a dangerous voltage held within that capacitor. The circuit is not dead until the capacitor is drained, and each capacitor does require a discharge path. Rule 26.22 deals with capacitor drainage, and there's two things we have to consider. First of all, we have to make sure that voltage gets down to a safe level, and the rule prescribes 50 volts or less as being a safe level. The second thing I need to worry about is how quickly do I need that to happen, and that's all based on what kind of voltage our system belongs to. The rule states that we must be down to that 50 volts or less within 1 minute in the case of capacitors rated at 750 volts or less, and within 5 minutes in the case of capacitors rated at more than 750 volts. If we're going to use a resistor as a discharge path, we have to be able to figure out how to size that resistor properly, and we're going to use the time constant formula that we used in theory. Take, for example, the capacitor that we have on the screen. Since it's rated at 460 volts, we know that we have to be able to get it down to a safe voltage level within a minute. My time constant formula that we used in theory had 5 different time constants to go from full charge to discharge. That means my 1 minute time frame is equal to 5 time constants. Inside my formula, my t for my time constant must be 1/5 of that minute, which is equal to 12 seconds. So my formula is going to be resistance is equal to my time divided by my capacitance. My time is the value of one time constant, which is 12 seconds. When it comes to my discharge path, Rule 26.22 sub-rule 3 tells us that the discharge circuit must be permanently connected with the terminals of the capacitor bank or provided with an automatic means of connecting it or removing it from the system. This means that we cannot rely on any manual control over my discharge path. It has to be connected to my circuit or automatically connected upon discharge. We can accomplish this by a two-way switch, whereas we can have the capacitor charge, and then when we turn it off, it provides a discharge path instead. We can also use things such as the windings of a motor to act as our discharge path as well. But then when we do that, we have to make sure that we are aware of where disconnects are and make sure that we have that discharge path so it is not interrupted. When we are required to install capacitors to offset a motor load, there are 3 general locations that capacitors can be placed, and these are all covered within Rule 26.218. The first example is to place the capacitor on the load side of the motor starter. In 26.218 sub-rule 1a, it states that motor capacitors on the load side of the motor leads do not need to have a separate disconnect, as they are automatically de-energized with the motor. And the motor also provides a discharge path, so we do not need to have any additional resistors. The motor circuit conductors, the disconnect, and the overcurrent are all sized according to the motor specifications, and we ignore what the capacitor does for the circuit. However, the conductors between the motor and the capacitor need to follow the same rules as 26.208 tap conductor rules, which means they cannot be less than 1/3 of the motor conductor ampacity, and they must be at least a minimum of 135% of the capacitor ampacity. The motor overloads are also selected to the corrected power factor of the capacitor bank with the motor together. If the capacitors are placed on the line side of the motor starter, they are treated as a separate branch circuit, and therefore we will follow all the rules of 26.212. We will require a separate disconnect as well as a separate discharge resistor across each capacitor according to Rule 26.222. As far as the motor control circuit is concerned, everything is based off the motor itself, including the conductors and the overloads, and we do not consider any power factor correction for the motor circuit. An advantage that we have with this type of setup is the fact that the capacitors will be affecting the total power factor of the building even when the motors are not in use. The third orientation we can have between capacitor and motor is to have the capacitors on the load side of the disconnect but on the line side of the motor controller itself. So we'd have the connection to the capacitors between the disconnect switch and the motor controller. In this case, the capacitors are still being protected by the motor disconnect switch, so they do not require their own separate disconnect, but since the overloads can disconnect the capacitors from the motor, we do require discharge resistors. The motor overloads are still based on the motor values of the full load amperage. Keep in mind, Rule 26.218 sub-rule 1 also applies here. When it comes to providing discharge paths for capacitors, we have to make sure that we can get the capacitor to a safe level quickly enough. And we can either do that using a separate resistor as a discharge path, or we can even use something like a motor winding in order to accomplish this. The most important thing for us to remember is that not only is that resistive path sized correctly to accomplish our goal, but also to make sure that there's no actual disconnecting between the capacitor bank and its discharge path, such as with the motor winding. If we have anything that could disconnect those two, then we have to make sure there's an alternate discharge path available for that capacitor bank. Up next, we will be talking about capacitor disconnects in Rule 26.212. In Objective 4, we're going to be looking at where to locate and what kind of ratings do we require for capacitor disconnects. And we sort of talked about this a little bit earlier when we were talking about conductors, but we're going to cover this information again. The rules for disconnecting means for capacitor feeder or branch circuits are all covered in Rule 26.212. First of all, we need to know that every capacitor bank needs to have a disconnect switch. And that disconnecting means needs to be within sight and not more than 9 meters from the capacitor unless the disconnecting means can be locked in the open position. So we have to be careful where we put it. We need to be able to make sure that if it is not in sight, it is lockable, and then we can do our proper lockout tagout procedures. Otherwise, we need it to be within 9 meters and within sight. Sub-rule 3 also states that a warning notice shall be affixed to the disconnecting means used on the circuits having capacitors only, and it needs to state two different things. First, it needs to state that the circuit has capacitors, and then it also needs to state that a waiting period of 5 minutes is necessary when the circuit is opened, after which the capacitors shall be discharged before handling. Of course, you should remember by now that my disconnecting means should provide me with a discharge path that will have a 1 minute time period for anything less than 750 volts or a 5 minute time period for anything over 750 volts. So the label is going to assume the worst case scenario and make sure it mentions that we need to wait a full 5 minutes before we enter that service box. When it comes to the current rating of my disconnecting means, I need to make sure I refer to Rule 26.214, which states that the disconnecting means for capacitor feeder or branch circuit shall be rated not less than 135% of the rated current of the capacitor. And this is the same rule I have with my conductors. We need to make sure that whatever the capacitor current is, the disconnect switch is going to be rated at 135% of that value. The only time I can get away from having a separate disconnect for capacitor bank is if my capacitor bank is wired with a motor, in which case Rule 26.222 allows me to use that motor disconnect as a capacitor disconnect as well, and I don't need to worry about it not affecting any other circuits. You've now reached the end of Module 205G on capacitor and capacitor banks, so please review this information and make sure you understand it well. Return to Blackboard, and then you can continue on to 205H.